Hi there, welcome to this video. My name's John, and in this video we're going to be taking a look at a problem that I've selected from a past paper for the mathematics admissions test. In particular, it's the 2017 MAT paper that we're going to be taking a look at, and it's question number 5 that we'll be having a look at in this particular video. So, if you're watching this video, you probably already got some familiarity with the structure of the MAT exam, but just to be clear, the MAT is such that the first question is usually a series of multiple choice problems, which tend to be less in-depth, not necessarily easy, but they're usually kind of single parts, and don't just guess the answers to those problems. You need to be grown up about it. You need to actually provide solutions to the problems. And once you get into question 2 and onwards, then you get onto more structured problems where you get presented with things that maybe you're less familiar with, new ideas, new concepts, which is entirely deliberate because you're being partly examined on your ability to receive and process new information and realize that you don't need to be spoon-fed everything. That you can be given a new idea, a new concept. You can be given a definition of a new concept, and then you can use logic to determine additional properties, further properties of this particular concept that you've been newly introduced to. Okay, why have I chosen this particular problem? The problem itself is not overly difficult. It's not really too difficult. What I had difficulty with was actually finding a way to clearly express my ideas. Because it's one thing to have an idea in mind about the solution to a problem, but if you can't communicate it, or if you can't communicate it clearly enough, you've got problems, right? You're not necessarily you can't get credit for something that you can't communicate clearly on a written exam. So it's really important that you do practice this, that you do practice expressing your ideas clearly. Don't just hope that it's something that will happen in your exam. Or even worse, don't just assume that somebody will understand. When you scroll a load of symbols on a page, don't just assume that somebody will understand what you've written. Remember, you have the benefit of having the idea. You might have written a load of symbols on the page. You have the idea in your head. You know what those symbols are supposed to be expressing. But try to put yourself in the shoes of somebody who is not privy to that idea that you have in your head and only has the symbols that you present them with. Try to be objective. Try to look at it from a bit more objective point of view. Could you expect yourself to understand what those symbols mean if you were given them without any further indication as to what they represent or anything like that? It does happen many a time as a private tutor where I'll get somebody that's attempted a problem and they present me with their solution to the problem. They want me to check it or give them some feedback or something, and sometimes all the feedback I can give them is, I've no idea what you've written here because it's just a page of Egyptian hieroglyphics. It makes no sense. Sometimes you might have to use these things called words, and you might have to actually explain things in plain English. Okay, yes, okay, there are certain strings of symbols that you can use that are widely understood to represent a particular thing. Okay, it's generally understood that this string of symbols represents this, and that's fine. But in some cases, the idea that you have might be more personal to you. And in that case, yes, use symbols where appropriate, but also, where appropriate, use words to explain give a bit more clarity. Okay, do this because you can't expect your examiner to kind of fill in the gaps. And sometimes it does happen where somebody presents you with a page of symbols and it's incomprehensible. Okay, They're written all over the place, and it's just scrolled on the page. And don't be that person. Okay, have a bit more consideration for whoever it is that's going to have to read your work. Okay, so I will leave a link to in the description to this video so you can download the past paper, and also throughout the video at various times I will put the problem up on the screen so that you can see it for yourself as you're watching the video. And okay, off we go. So there's quite a bit of information that we're given. It's a very simple situation, but okay, let's take a look. So 10 children, C0, C1, C2, up to C9 are seated clockwise in a circle. The teacher walks clockwise behind the children with a large bag of sweets. When it says large bag of sweets, what that means is that there's going to be sufficiently many sweets for us to do whatever we need to do with this problem. Okay, we're not going to run out of sweets or anything like that. She gives a sweet to child C1. She then skips a child and gives a sweet to the next child, C3. Next, she skips 2 children and gives a sweet to the next child, C6. And she continues in this way at each stage, skipping one more child than at the preceding stage before giving a sweet to the next child. So make sure that you understand this information. It's very simple in this case, but nevertheless, even a simple problem requires a certain level of understanding. Something that I just want to point out before I continue with this video, and something that I've mentioned in some of my previous videos where I go through MAT and step problems and things like that, this is not meant to be a model solution to this problem. If you want a model solution, I recommend you watch another video, somebody else going through this problem, or you refer to a mark scheme or whatever, okay? The point of these videos that I make is that I go through the problem solving process, and I highlight in some cases what some of the difficulties are in the problem solving process, and some of the things that you might have to do or you might find useful to do to overcome some of those difficulties. Okay, so not everything that I do in this video or my other similar videos is necessarily directly pertinent to the solution to this problem. In the respect that if you were to write out a model solution, some things that I do are going to be arguably superfluous or unnecessary. Okay, but some of those things that I do because it helps me to understand the problem, and it might be something that going forward you might find useful as well. You might not. Okay, you might not find it useful, but sometimes you have to do what you have to do to understand the problem, to solve the problem. You can't expect to just write out a model solution first time every time. Just doesn't happen like that. Sometimes you've got to do things that are unique in many ways to you in order to find your solution to the problem. So I'm not going to be cutting that sort of stuff out. So that will make the video a bit longer than it needs to be in many respects. But also, I'm not necessarily going to write everything out because, particularly for this first part, there's a bit of a... You would have to write quite a bit, potentially, to explain what your idea is going to be. I'm going to be explaining in words, and I'm going to write a bit on the screen, but I'm not necessarily going to write absolutely everything out on the screen. Otherwise, because it takes quite a while to write with this stylus thing. So I don't really want to drag the video out too long, only as long as it needs to be. Okay, so the first problem is the kth sweet is given to child CI. Explain why I, that's the index here that we're talking about. Explain why I is the last digit of the number k times k plus 1 over 2. Okay. Hopefully you recognize k times k plus 1 over 2 as the sum of the first k natural numbers. In other words, 1 plus 2 plus 3 plus 2k. This is equal to k times k plus 1 over 2. If you don't recognise that, you should. But what we really need to do is we need to a certain extent, understand why this particular expression has come up. Okay. So, what I did initially with this was the following. I drew out, you can draw out diagrams, whatever you need to do, right? Don't be afraid to do what you need to do when it comes to solving problems and understanding the information. And take your time with this. It takes as long as it takes. So, some of you already will have completely understood the information that we've been given. And good for you. It just happens sometimes that problems are presented to you in a way where you've got to take a little bit more time than somebody else to understand. It applies to me, it applies to everybody. Okay, so some people will get it like that, but you've got to take a bit more time. But then for other problems, the roles are reversed. The problem is presented in just such a way for you to understand it right in a flash. Somebody else has to do a bit more work to understand it. Okay, so if you've got to take a bit of time to understand the problem, take your time with it. Okay, you need to understand the problem before you can really start to answer it. Okay, so I drew out this diagram or table, whatever you want to call it. So we had k, which is the suite number. Okay, so suite number 1, suite number 2, suite number 3, suite number 4, 5, 6, 7, and so on and so forth. So then I made a note of which child receives each of these suites. So child C1 receives suite 1. Child C3 receives suite 2. Child C6 receives suite 3. We know this because we're told. But then I need to start figuring out how to calculate which child is going to receive suite 4, 5, 6, 7. So this is me personally just figuring out this situation. And there is actually more to this. For me personally, this was quite revealing in many ways, some of the patterns. Okay, so if we look at rather than looking at the when the suites are handed out, what I did was just to think more in terms of the teacher just walking behind the seats. So the children are all seated on these seats, and the teacher just walking behind them. Forget about the suites. What's happening as the teacher is walking behind the children? Okay. So when I say forget about the suites, it kind of recedes into the background. It's still there. It's still something that we're going to have to consider, but it takes a less prominent place in the way that I'm thinking about this problem. So then we might have n. So n, I'm going to uppercase n, is the symbol that I'm going to use to represent the total number of seats that the teacher has stood behind. Okay, so when the first suite is given out, it's 1. Okay, that's when the teacher starts. So then what happens? Okay, the teacher passes a chair and then goes to the next one, hands out the next suite. So she's passed two seats. 2 more seats. So there was the first seat, and then there's the next 2. Then she passes 2 more chairs before so she skips 2 children, comes to the next child and hands out a suite. So that's 3 chairs in total. So plus 3. So the next one is going to be plus 4. And then plus 5. And plus 6. And plus 7. Aha, okay. So can you see what the pattern is here? Every time a suite is handed out, the teacher has stood behind a total of, well, let's say the fifth suite is handed out. The teacher has stood behind a total of a total number of seats which is equal to the sum of the first 5 natural numbers. We can see from this that when the teacher hands out the kth suite, she will have stood behind a total of 1 plus 2 plus 3 plus 4 up to k seats, but that's equal to k times k plus 1 over 2. Right? So now, through this diagram that I've drawn, I can see how this formula, k times k plus 1 over 2, how that comes into play in this problem. Little things like this that have helped me to personally understand how this information is relevant to this particular problem. Some of you might have seen this much sooner than I did, and good for you. But again, you've just got to do whatever you need to do to solve the problem and to understand the information that you've been given. Maths made easy. Maybe we could get some MAT made easy mugs. Okay, so when she hands out the third suite, she's standing behind child C6. She goes forward. She goes around another 4 seats. What happens? Again, there's another point here that we need to observe. She's behind C6, C7, C8, C9, C0. This is an example of what's called modular arithmetic. Okay? So if you're not familiar with modular arithmetic, it's sometimes called clock arithmetic. Because think about what happens with a clock. You've got the numbers 1 to 12 on the face of a clock. You go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then what happens? You go back to 1. You don't continue on to 30. Well, unless it's a 24-hour clock. But we're just talking about a 12-hour clock face. You go back to 1. This is an example of modular arithmetic, except with modular arithmetic, typically or conventionally, you would start at 0. Okay, so rather than having the numbers 1 to 12, you'd have the numbers 0 to 11. So you'd go 0, up to 11, then you'd go back to 0 and go around again, then you go back to 0. So that would be arithmetic modulo 12, where you go from 0 to 11, and then where you would go to 12, you go back to 0, in fact. What we've got in this problem is arithmetic modulo 10. Okay, arithmetic modulo 10, you go from 0 round to 9. Then what happens? Rather than going to 10, you go back to 0. That's going to be important, a very important observation to make. And it's through, again, kind of drawing this diagram out that it drew my attention to this bit of information. Okay, so then the next suite will go to C0, C1, 2, 3, 4, 5, C5, right? C5, go forward another 6, C6, C7, C8, C9, C0, C1. Okay, and so on and so forth. I can't bother with the rest. You get the idea. Okay, so hopefully you've seen exactly how this is going to work now. If not, I'm going to explain it anyway. But the key, this with modular arithmetic, that's the key to this. That's the key to this. Because again, if we refer back to n, which is the total number of seats that the teacher has stood behind at a given time, think about the final digit of that number. Okay, so it's going to go as the teacher passes each seat. This number will increase by 1 each time. So it goes it goes 1. So the final digit, will. The number will increase by 1 each time, but also the final digit will increase by 1 each time until when? Until we get to 9. So it goes 1, 2, 3, 4, 5, 6, 7, 8, 9. Then back to 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. Back to 0. this is exactly what's happening with the index of the C's, where we go child C1, C2, C3, around to C9, C0, C1, C2, C3, and so on and so forth. So we can see how the behavior of the index of the CI's, so the index is this I here, and the final digit of N are going to match up. The idea is obvious, right? The idea is obvious, but now we've got to find a way to put that in, to express that. This is what I had most difficulty with, really, actually finding the right kind of words to express this. You don't need to be perfect with this, okay? You don't need to be absolutely word perfect. You don't need to be a wordsmith or anything, but you have to make your idea clear to somebody who's trying to understand your solution. So don't fret about it too much, but do try to be objective when you read what you've written, when you read it back to yourself. Just make sure, ask yourself, if you were the examiner, or if you were somebody that didn't know what the original idea was that was being expressed, would you be able to still kind of get a good feel for what the idea was? Okay, so the teacher, so N is the total number of chairs that the teacher has stood behind and teacher starts behind chair C1, and in which case N is equal to 1. Okay, so what happens? The index, so as the teacher moves clockwise around the circle, two things happen. The index of C I increases by 1 each time. Up to 9, and then goes back to 0. So I'm not writing out necessarily in full sentences here. I'm explaining in words a bit more. Otherwise, it's just going to take too long for me to write absolutely everything out. But have a go yourself. Have a go at writing out. I've given you the idea. Make sure that you understand the idea. It's much more important that you understand the idea rather than just know the solution. But try to express it in your own words. My words are my words. Even if I did write out full sentences here and paragraphs and everything and whatever I needed to do, they're my words. They're my way of expressing this idea. You've got to find your own way of expressing this idea. Okay? And we've also got the final digit of N increases by 1 each time. When I say each time, I'm talking about each seat that's passed. Up to 9 before going back to 0. So from this we conclude that I is equal to final digit of N. Now this is not actually what we've been asked to do, because what I've shown here is that as the teacher stands behind a seat, irrespective of whether the teacher gives a sweet out or not, the final digit of N will always match the index of CI. So whichever number child the teacher is standing behind, N is the total number of chairs or seats or children that the teacher has stood behind. These two will always match up. even as the teacher passes those seats where she doesn't actually hand out a sweet. Okay, but if it holds for all of these chairs, for every seat that the teacher stands behind, it holds also for those seats that the teacher stands behind where she actually hands out the sweets. Okay, so in particular, so this is true even at those times, those seats, those times, those points at which a sweet is handed out. Is handed out. Okay, when is the kth sweet handed out? Again, we refer back to the diagram, and this is where this might actually become part of your solution, part of your explanation. The kth sweet, when the kth sweet is handed out, n is equal to 1 plus 2 plus up to k, which equals k times k plus 1 over 2. Therefore, so the index I is equal to final digit of k times k plus 1 over 2. Okay. So this is a very rough and ready explanation that I've given here. Have a go yourself at finding your own way to express this particular idea, rather than just using my words. Okay, I've given you the idea. Hopefully I've explained it clearly enough for you to understand what I'm talking about. If not, any questions that you have, just leave them in the comments section. I'll get in touch. I'll be more than happy to provide some clarification. Okay, so moving on then to the next part. And I'm going to scroll down a bit just to give myself a bit more space. Okay, right. So, part 2. Let 1 less than or equal to k is less than or equal to 18. Explain why the kth and 20 minus k minus 1th sweets are given to the same child. Okay, so this to me seemed kind of obvious how to do this, but I'll explain. So the kth sweet is handed out when the teacher has passed, when the teacher has stood behind k times k plus 1 over 2 seats. And the 20 minus k minus 1 when the teacher has stood behind 20 minus k minus 1 times 20 minus k over 2. Okay, so the idea is that if the difference between these two numbers, is a multiple of 10, then those sweets will be given to the same child. Okay, and this 1 less than or equal to k is less than or equal to 18. This will play more of a role later. Okay, so don't worry too much about that right now. I mean, it is kind of necessary because 20 minus k minus 1, we're kind of limited as to the values that k can take there. But it will become much more apparent what the relevance of this particular string of inequalities is further down the line. Okay, so let's go for it then. Let's go for. Let me get rid of these things here. So this is equal to k squared plus k over 2, and this is equal to. So it's 400. I've got my notes here just so hopefully I don't make too many silly mistakes. Minus 20k plus k squared plus k over 2, which also happens to be equal to, when you kind of notice that we've got the k squared plus k. This was just something that I noticed fairly quickly when I did this. We've got the k squared plus k over 2. So we get, when we simplify, 200 minus 20k plus k squared plus k over 2. Okay, so now if we find the difference of which way round shall I write? It doesn't really make any difference, I suppose, does it? So we've got the difference between 20 minus k minus 1 times 20 minus k over 2 minus k times k plus 1 over 2 is therefore equal to 200 minus 20k, which is equal to 10 times 20 minus 2k. Okay, because the k squared plus k over 2 is gonna cancel because we're subtracting here. So since the difference, again, I'm just going to kind of give a rough idea, you express in your own words. So the difference is a multiple of 10. So, and because 10 is the number of children in this circle, right? It's a multiple of 10. So since there are 10 children in the circle, sweets k and 20 minus k minus 1 go to the same child. Okay, easy peasy. Easy peasy, squeezy lemons. Righto. So, on to part 3. By the way, if you do find these videos useful, please show your support for this channel by hitting the subscribe button and hitting the like button. I don't make any money from making these videos. I make them because I want to make them and I want to help people prepare for their MAT and STEP exams and further maths exams and so on and so forth. So I'm only really going to continue to make these videos if I do have some support for doing so. And I'm not necessarily talking about financial support, just that people appreciate these videos. If people don't want them, I won't make them anymore. So if you do want me to continue making them and you want these videos to remain freely available to you, just hit the subscribe button. It doesn't cost anything. Takes a fraction of a second to do. And also, if you do know anybody else that's preparing for these exams that might find these useful, share these videos with them. Also, I'm open to feedback with my videos. If you think there's anything that I could be doing better, I'm open to suggestions. Just because somebody suggests something doesn't necessarily mean that I'm going to do that. But if you've got any ideas about anything, let me know. And if it's a good idea, if it's something that I think, yeah, that could make my videos better, then, it's something that I can incorporate into my future videos. Okay, so let's continue. So, where are we up to? Part 3. Explain why the kth suite is given to the same child as the k plus 20th suite. It's the same kind of thing, right? We've got the kth suite. The teacher has stood behind k times k plus 1 over 2 seats, and k plus 20th suite, k plus 20, k plus 21 over 2. This is... got a bit ahead of myself, haven't I? K plus 20th suite. This is equal to k plus 20, k plus 21 over 2. This in turn is equal to, what did I get? K squared plus, Okay, I wrote it originally as 41k plus 420 over 2, but I was always looking to do a similar kind of thing to what I did in the previous part. So remember, this was equal to k squared plus k over 2. Well, it turns out that this is also equal to k squared plus k over 2, plus, in that case, we'd have 40k plus 420 over 2, which is going to be 20k plus 210. So the difference, again, I'm going to skip a little bit of stuff. It's just a rough solution, a rough idea of the solution. The difference is equal to 20k plus 210. So we're just doing this, take away this, which of course is equal to 10 times 2k plus 21, which is a multiple of 10 again. And since there's 10 children in the circle, that means that the kth suite and the k plus 20th suite are given to the same child. Okay, easy. Easy, easy, easy. Part 4. Oh. Part 4. Which children can never receive any sweets? This is awful, isn't it? Imagine being in the circle and not receiving a sweet. How awful. Okay, so the way it's kind of a brute force way of doing this. Okay, we've already done part of the work. So if we think about k, the different values of k. So we go from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so the first suite goes to child C1, second suite goes to child C3, C6. I think I've got it written out here. So C0, C5, C1. The next one goes to C8, C6, C5, and then we can start to use the results that we've just figured out, right? So from part 2, the child, whichever child receives suite number 9 will also receive suite number 10, because remember, the child that receives the kth suite also receives the 20 minus k minus 1th suite. Right, so if k is equal to 9, then 20 minus k minus 1 is 10. So that's going to be child C5. And now we just kind of work back along this sequence, right? So C5, C6, C8, C1, C5. Hopefully I've not made any mistakes here, by the way. Let me know if I have. I'm not perfect. C1, oh, okay, but what about 19 and 20? Because I wanted to use that property from part 3, that the kth suite is given to the same child as the k plus 20th suite. So I know that the 21st suite is going to go to child C1, and effectively we're going to cycle through all of these again. All of these, so C1, C3, C6, C0, C5. But what about 19 and 20? Well, I've just got to figure them out, right? I've just got to figure them out. So the 18th suite is given to child C1, so I need to effectively add 19 onto that. But remember, we're doing modular arithmetic. So if I add 9 onto that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. We're back to 0. Then when I add 10 onto that, I get back to 0 again. So the 19th suite goes to C0. Then when I add 20 onto that, 20 is a multiple of 10. So if child C0 received the 19th suite, child C0 will also receive the 20th suite. Okay. And whether there's a quicker way of doing this, I don't know. I've not really investigated in that much detail, but this seems to be as quick as any way. Yeah, okay, you've got to write a bit of stuff out. And it might seem unsophisticated, but it certainly gets the job done. And I haven't seen a quicker way of doing it. But let me know. If you come up with a better way of doing it, I'm all ears. Okay, so then we'll just go through which children are not represented anywhere here. So we've got C0. Well, actually, okay, let's start from the beginning and let's work through methodically. So we've got C1, C3, C6, C0. So these are not, obviously, the indices are not necessarily in numerical order here. C5, we've got C1, which we've already got. C8, C6, which we've already got. C5, we've already got. C5, C6. Well, obviously, we're going to have all of these. C0, we've already got. So these children, C1, C3, C6, C0, C5, C8, they do receive suites. And children C2, this is awful. C4, C7, and C9 do not receive suites. Okay, so four of the 10 children don't receive any suites. Okay, and yeah, that's that done. So it does seem a little bit unsophisticated, but we're using the results that we've already obtained. You know, the part 2 and part 3, we were establishing certain results, establishing a certain pattern. We're just using that pattern. Perfectly legitimate thing to do. So part 5. There's a bit more information for us. When the teacher has given out all the suites, she has walked exactly 183 times round the circle and given the last suite to C0. How many suites were there initially? Okay, so she's walked exactly 183 times round the circle. So that means that she stood behind, at this point, n is going to be equal to 1,830. So we effectively need to solve the equation, if I'm not mistaken, k times k plus 1 over 2 is equal to 1,830. Okay? So that means that k times k plus 1 is equal to 3,660. And this is where it's kind of useful for you to be able to recognize square numbers and things like that and patterns within numbers. So all of the times when I tell my students, for example, not to use the calculator to do everything, because if you use a calculator to do everything, you don't learn to pick up on certain patterns, certain relationships that are there. Bearing in mind that in this exam, the MAT, you won't have a calculator. You've got to do this without a calculator. So I recognise this straight off the bat, and that's not meant to be some kind of flex or brag or anything like that. It's just, I did. I spotted this straight off the bat. This is equal to 3,600 plus 60, which is equal to 60 times 60 plus 1. So k is equal to 60, for example. Okay, so there were 60 suites altogether initially. By the time she's walked 183 times around the circle, and it's all of these little things as well that I've done previously. All the little things that maybe initially didn't seem to really be pertinent to the solution to the problem. Actually, further down the line, they've really helped me to understand the problem with greater depth and in sufficient depth for me to be able to actually produce a solution to the problem. So k is equal to 60. That was the initial number of sweets. Okay, and then vi. Which children received the most sweets and how many did they receive? Okay, so this is, again, kind of straightforward. We can actually use what we wrote out in part 4 to figure this out. Because remember, which children... Oh, so this follows on from part 5. So we're still dealing with 60 sweets have been distributed. So remember that the cycle kind of repeats every 20 children. Every 20 sweets, sorry. So the teacher hands the first 20 sweets out, and then it's effectively going back to the beginning, and the exact same process repeats all over again, right? So remember, whichever child receives the kth sweet receives the k plus 20th sweet. So if I know which children received the first 20 sweets, which I do because I've already written that out, then I know which children receive sweets 21 to 40 and which children receive sweets 41 to 60. Okay, so if we go back to the diagram, I'm not going to bring it back up on the screen. Actually, I'm going to have to, I think. Yeah, okay. So all you've got to do really is go along here and so maybe where can I write it? So I need to keep that up on the screen here. So let's write it out here. So we've got C1 to C8 that we need to account for. C1, C2, not C2, sorry, C3, C6, C0, C5, and C8. Okay, so in this first lot of 20 sweets that gets handed out, C1, I'm going to do it as a tally. So it's C1, C3, C6, C0, C5, C1, C8, C6, C5, C5, C6, C8, C1, C5, C0, C6, C3, C1, C0, and C0. Stop there, okay? So in 20 sweets, C1 receives 4, C6 receives 4, C5 receives 4, C3 receives 2, C0 receives 4, C8 receives 2 sweets. So in 60 sweets, I just multiply these by 3. So which receive the most? It's going to be C1, C6, C5, and C0. So it doesn't say which child received the most sweets and how many did they receive. It's which children. Okay, so it's accounting for the possibility at least, and the actuality, as we see, that there is more than one child that receives the most sweets. There's actually 4. So it's C1, C6, C5, C0. So C0, C1, C5, and C6 all receive the most sweets. And how many do they receive? They receive 12 each. Remember, they got 4 in that first cycle of 20. They got 4 sweets each. So multiply that by 3. They're going to get 12. Okay, and you can check this because if each of these children, C0, C1, C5, C6, received 12 sweets, that's 12 times 4. The other 2 children received 2 sweets in the first cycle of 20. So in 60, they're going to receive 6 sweets each. So plus 6 times 2, that's equal to 48 plus 12, which is of course equal to 60, which just gives us a bit of confirmation really that we're on the right tracks. Okay, and that is it. We're done. So, if there's any questions that you have about anything that I've done, please let me know. If there's anything that you want to add, let me know. If you need any further help with anything, preparation for your exams, if you want to work a bit more one-to-one, get in touch. Be very happy to have a discussion with you about what your needs are, what your requirements are, and how I can help you. Please hit the subscribe button, hit the like button. If you've made it to this point, congratulations. If you are preparing for your MAT exam or STEP exams, best of luck with that. And hopefully, I really hope that these videos do help you to prepare. But on that note, I'll say thank you very much for watching, and I will see you in the next video. Thanks a lot.